and we have some folks joining in as well. Hi everyone, I welcome you all to this workshop on harness chaos engineering. For this, I'm your host Arthajan, and I'm a senior software developer at Harness alongside your co-host Saranya. And yeah, we have with us Neelanjan and Udit for this workshop. So yeah, they both are software developer at Harness, and I'll not take much of your time. Yeah, I'll hand over the stage to you guys.
Thank you so much, Sarthak. Hey, folks, welcome everyone to Chaos Carnival. I hope that you had some amazing sessions so far. So, yeah, without any further ado, let's actually jump onto this workshop. Joining with me is Udit. As you already heard, Udit is a senior software engineer at Harness, and let us take an introduction of him.
Hello everyone, I am senior software developer at Harness and I welcome you all into today's session. Hope you will enjoy the workshop.
Thank you so much, Udit. So here's how what we'll do. I'll take the first session of the workshop where we'll see that how you can set up the harness chaos engineering, and we'll see that how simple it is to get started with your chaos engineering requirements using harness chaos engineering. After that, Udit will come along and he'll show you some of the experiments that we can execute using harness chaos engineering. So first of all, so that we are all on the same page, I would like to share a workshop guide with you guys. So we'll be following the steps from this guide, and alongside, we'll be following the steps hands on so that you can follow them along as well. So I'm sharing this guide with you right now through the chat. I hope you guys are able to see the chat right now, and I have set this GitHub README wherein you will be finding the steps that we'll be following along through this workshop. So let me also just share my screen so that we can all run along the guide for once. Udit, can I have a kind confirmation if the guide is visible or not?
Yeah, it is visible.
Thank you. So yeah, along with this workshop, you'll be gaining some hands-on experience with running and executing chaos experiments via harness chaos engineering. We'll be first creating a sign up for the harness SaaS platform so that we can execute our harness chaos engineering experiments. So after we'll be creating the account in the harness, we'll proceed to obtain a sandbox environment where you can run your chaos experiments. So this is a particular Kubernetes cluster that you'll be obtaining via harness, and we'll be using this cluster to run your chaos experiments. Following, we'll be setting up the chaos infrastructure, that is basically an agent which will be sitting within your Kubernetes cluster in order to execute the chaos experiments, followed by connecting a custom chaos hub. We'll learn all about it in the demo, followed by the experiments that we'll be performing today. We'll be performing a total of 4 experiments today, including the boutique cards pod bounce, boutique cards degraded network, boutique card CPU starvation, and finally boutique multi-fault scenario. Each one of these experiments will combine different thought processes that involve in the chaos engineering execution, and we'll also learn a few concepts involved in the harness chaos engineering, such as the resilience probe, or what we call as chaos probes. And we'll also see that how you can customize these experiment and mix and match different faults in a single experiment, to name a few things. So yeah, we have a packed agenda. Without any further ado, let's jump right into it. But before we actually proceed, let me just remind you the tools at your hand. So in case of any question, please feel free to use the Q&A tab to post in the questions. Udit or I will try our level best to answer you. And at the same time, you can also reach out to us in the Chaos Carnival Slack channel wherein we can take your questions. Apart from this, in case you're not able to catch up, let's say, with the pace of our demo, please feel free to alert us so that we can repeat the step for you. And if you're still unsure of what's happening, you can definitely refer to the recording of this demo, which is accessible in this link. So, as you'll come to the guide, that I'm showing right now, you can just refer to this recording, wherein a complete recording of the workshop is available for your reference. So, yeah, with that, let us start. So, the first step that we are going to do today is enter into the Harness SaaS platform. A brief intro to the Harness SaaS platform. It's basically a conglomeration of different offerings of the Harness, different product offerings by Harness. We have different modules such as the continuous delivery, continuous integration, service reliability management, feature flags, cloud cost management, and finally the chaos engineering. Fun trivia: chaos engineering is the youngest module in the Harness platform. So, yeah, without any further ado, let's try to do a sign up for the Harness SaaS platform. Assuming that you don't have an account with the Harness SaaS platform, just try to access the app.harness.io. For your benefit, I'll just copy the link for you guys. So I would request you guys to kindly log into this page. Sorry, just access this page. We'll be doing the login process together. All right. I guess we all are on the same page at now. All are in the sign up page. So the process of sign up is very simple. Let us try to sign up with our email. Kindly use your email so that we can map your accounts, the Harness accounts, with the sandbox environments which you'll be doing. Now please pay attention here to the sign up process. We'll be signing up with email, so I'll just simply select the sign up with email, and in here I'll be providing my email. And then you can provide any password and simply select sign up. Now it should prompt you to verify your email address. So go to your inbox and try to see if you have received an email from Harness. So let me just open my inbox over here. And if I refresh over here, I have received an email from Harness requiring me to verify my email address. So I'll just simply verify my email address here. So assuming that everyone is able to get into your Harness accounts and you have been able to verify your email accounts, we shall proceed forward. Or do we have any issues? All right, I guess no issues so far. Good go along. So we'll just go back to this module. As you can see right now that upon verifying my email address, I'm here in the screen where I can start with the Harness platform. And over here, we need to select the module that we need to get started with. So we'll start with the chaos engineering module because that's what we're here for. So I'll just select chaos engineering and select continue. All right. So it looks like we are successfully able to enter into our chaos environment, our chaos module within Harness. And this now enables us to perform chaos experiments on our target infrastructure. But again, what is our target infrastructure or wherein our target infrastructure lies? So let's actually try to obtain a target infrastructure via Harness. So if you will go back to the guide and scroll down, you'll be able to see that we can obtain a sandbox environment to run our chaos experiments, which will be provided to you by Harness. So let us try to run down the details of this process. We need to fill up and submit a form such that we'll be obtaining a sandbox environment that is basically your Kubernetes cluster, which will be valid for a total of 6 hours. So, after filling the form under 2 minutes, you shall be receiving an email with the receipt of your sandbox config information. which includes basically a kubeconfig file via which you will be able to connect to your Kubernetes cluster, along with a sample microservice application, which will be serving as our target application throughout this demo. So it will be containing the URLs, the email will be containing a URLs to the microservice application, which is the boutique application, about which we'll learn in a short while, a Grafana dashboard, which will be serving as the monitoring aid for the entire platform, and a Prometheus metric server endpoint as well for the purpose of Grafana visualization. So let us try to obtain a sandbox environment right now using the form. So I have already the form open with me, and I'll use my email address in order to create my form. So I'll just provide my name over here and my organization, also my email. And finally, I also need to provide my harness account ID. So the way you obtain your harness account ID is you simply need to go to your account wherein you can see your the screen where it says to enable your chaos infrastructure, and copy this link provided here. This happens to be your account ID. So I'll just again repeat this step in case someone didn't pay attention, since this is very important. The way to obtain your harness account ID is you simply go to the tab where your harness SaaS platform is open, and you copy this ID in the URL which is after the account subroute. So I'll just simply copy this ID and I'll provide this here in my form. So once you verify that all the information that has been provided by you is correct, please feel free to submit your application, your request. All right. So here's submission of my request. So now we should duly receive, uh, we should really duly receive the kubeconfig and the Grafana and the application, the target application that we'll be using for this demo in my inbox under 2 minutes. So, meanwhile, let me know if you are able to still use this platform or not, or if you're facing any problems via the chat or through the Q&A section. Oh, yeah. Let me remind you that please take your screenshots and send them to the Chaos Carnival Slack channel so that we are able to evaluate submissions. Okay. Let us wait for a while for to receive our request. Meanwhile, please feel free to post in any of your questions via the chat. We are here to help you guys. We can help you with any of your queries. Udit, can you please create a poll through which we'll be able to know whether all the users are able to successfully set up until the stage or not?
Yeah.
Thanks. All right, folks. So, assuming that you guys were also able to successfully submit your application request for obtaining a sandbox environment, uh, here we can see that I have already received my sandbox environment, which is catered to you know uh, my requirements, so that I can proceed with this demo. You shall be obtaining a similar email, such as here. So let us wait for a few minutes so that all of us receive our emails and we can then proceed forward. Awesome. Jose says that he has received the sandbox environment. Awesome. So kindly respond to this poll through which we'll be able to know whether you are able to access the sandbox environment or not so that we can proceed forward with the demo. Awesome. So we have 7 votes right now, which says that they were able to receive the sandbox environment. Awesome. 8 votes, 9 votes. Awesome. Awesome. So let us wait for a 1 more minute so that all of you receive your sandbox environment and we can proceed forward. Okay, someone says that they weren't able to receive a sandbox environment. I would advise you to just wait for a few more minutes so that we can ascertain whether it's really an issue. Otherwise, just be on the lookout in your inbox to receive the sandbox environment email.
Yeah, it will take you some 2 to 3 minutes after you did the request to receive the information in the mail. So please hold on for that time.
Yeah, sure. So, okay, Jesse says that he's not seeing how to start. He is late. So, Jesse, I'm just sharing a recording with you for your benefit. You can quickly catch up to us if you watch this recording, and you'll be able to follow along now. I'm also sharing the workshop guide link once again for your benefit. All right, we have around 17 votes in. I hope that most of you have received a email from for the work for the sandbox environment. So we can close the poll now. Udit, kindly facilitate the request for the ones who are not able to receive any sandbox environment so that we can proceed with the demo. All right, folks. So congratulations. Now that you have received this email, let's right now go to the next step where we'll be using this information in order to create our sandbox environment, and we'll see what is inside it. So the email, as we already also noticed, provides us access to 3 different URLs, namely the boutique website, the Grafana dashboard, and the Prometheus metric server. So the boutique website, the first URL, let us try to access it. As we can witness over here, it's an e-commerce application which will be serving as a demo application for the purposes of our demo. So we'll be using this application for targeting the chaos, and we'll be monitoring the effects through this. So let us actually go back to our email, and we can also see that we have received a Grafana dashboard deployment URL. So if you try to access it, and we need to log in over here. So the default credentials for Grafana dashboard is admin for the username and admin for the password. Please remember this. It's admin for the user name and admin for password. If you'll try to log in, so if you log in over here, you can select dashboards, and inside that browse. And if you'll open this general folder, you'll be able to see the boutique app dashboard. So please open that. And in here, you will be able to see a Grafana dashboard which monitors the application behavior, and you will be able to see the current status of the different microservices belonging to our boutique application. So let me just do a quick rundown of all these graphs, all the information that you're witnessing over here. First, we have the probe success percentage, which refers to the availability of the entire website. So it says that currently the probe success percentage is around 100. So it means that the application behavior is quite healthy. And the other microservices include the front-end QPS, the cart QPS, and the product QPS. These are the queries per second experienced by the different microservices. So as you can see over here, our website is working right now. Our Grafana dashboard is ready, and everything seems neat and tidy. We'll further learn about what those graphs can help us interpret as we move further along the demo. But right now, we would be trying to access these resources via our Kubernetes cluster. So, just for comparison's sake, or just for our understanding sake, we can argue that these services are definitely deployed somewhere. So to demystify it, of course, it's deployed in a Kubernetes cluster, and the Kubernetes cluster it's deployed to, you can definitely access them so that you can understand how Kubernetes chaos engineering is targeted via harness chaos engineering throughout the demo. So without any further ado, let's try to do that. So I'll head back to the email that we have received, and you can observe that it also contains a kubeconfig file over here. I'll just try to download this file. And upon downloading this file, now we can actually use this file in order to access the Kubernetes cluster within which our boutique application as well as our observability stack has been deployed. So to do that, it's important that you have kubectl. For the uninitiated, kubectl is a CLI tool used for interacting with Kubernetes clusters. So in case you don't have kubectl, please feel free to install it via this website. I'm sharing the link in the chat. This will be a very quick step, so I'm not going to go through how you can install kubectl, and assuming that majority of you already have kubectl installed, I'll just assume that you have kubectl and move to the next step. So yeah, assuming that you already have kubectl, I'll just select my terminal over here. And after logging into your terminal, what you need to do is you need to add this kubeconfig file to your context, to your kubectl context, so that you can switch to that context and view the different resources within your namespace, your assigned namespace. So the first step is to add it to the context. So for that, what you can do is you can export the kubeconfig files configuration to include this file which we have downloaded as well. So here's the thing: for the uninitiated, kubeconfig file usually lies at a directory which is within the .kube/config, and along with that we'll be trying to append the file that we have just downloaded. So to do that, we'll be using this command export kubeconfig, and after that we'll be using the location of the file which we already have, that is home directory /.cube/config. Then we'll be adding a colon and simply giving the path of the file that we just downloaded. So, which in my case happens to be home directory slash downloads slash my name dot kubeconfig dot yml, right? So this is the path that you need to provide over here. So I'm just copying and pasting this command in the chat for the benefit of you guys, and I'll be again repeating the command that guys need to execute. So you can see that the command that we need to execute is uh, export kubeconfig equals home directory slash dot cube slash config and a colon followed by the path of the file that you just downloaded. This will enable us to use the context of the cluster that via the kubeconfig file that we have just downloaded. We can also open this file and observe that it has a few credentials of the cluster that we are going to use over here. So according to this, we have a token of a service account which will be mapped to the namespace, for example, which will be assigned to you, about which we'll be just talking about. But the more important part is the name of the cluster over here. The name of the cluster is this whole long name. This will help us to select the cluster config right now in the next step. So assuming that all of you were able to export your kube config over here, the next step is to select the kube config cluster information. So I'll just do kubectl config, use context, and after that, the name of the cluster. So the name of the cluster is, for example, in my case, GKE HC play US Central 1C underscore unscripted demo cluster. So this name will be same for you guys as well. I'll use this name over here. And as you can see, we have switched to the context of this cluster such that all the commands that we'll be running right now will correspond to this Kubernetes cluster. So I'll also copy this command for you guys such that you will be also be able to execute it directly. All right. If you guys have any issues following me up until here, please let us know via the Q&A or the chat so that we can help you. All right. Can I please have a note of if anyone is not able to follow so far so that we can help you get along? Otherwise, we'll just move forward. Awesome. It looks like all of you are following along well. Very nicely done. We are already playing a lot with Kubernetes, but yeah, it's time for the real game. That is how we can use chaos engineering. So yeah, right now we have access to our Kubernetes cluster. And what we are going to do next is gain access to the namespace within which our pods exist. So the namespace in this case has been predefined within which the pods lie. So to the namespace that, for example, has been assigned to me happens to be my first name and my last name followed by an S. So this happens to be my namespace, and in your case, it will be your first name hyphen your last name hyphen ns. So it is being obtained by that form that you had submitted a while ago. So please ensure that whatever first name and last name you were using in that form, make that into lowercase, the first letters lowercase, and try to access your Kubernetes cluster via that namespace. So if I execute this command, for example, I'm able to see the status of all the application pods that are running over here right now. But yeah, before we move forward, let me just repeat the command that you need to use. It's kubectl get pods, basically kubectl get pod, for we are trying to get the application microservice pods that we are having in our namespace, followed by the namespace itself, that is dash n, and the namespace name, that is your first name hyphen your last name hyphen ns. So I'll also just put this command into the chat for anyone's reference. Cool. So yeah, if we execute this command, as you can see, we are getting access to all the application pods that are running in our cluster right now. So what do these mean? Well, it refers to the different pods that this boutique app application uses. So we have the ad service, the cart service, the checkout service, currency service, email service, payment service, product catalog service, so on and so forth. A host of different microservices, since because well, the boutique application is nothing but a bunch of microservices. Also, we can see that we have the pods for our monitoring stack, that is our Grafana, and we also have the Prometheus pods, including the Prometheus deployment as well as the Prometheus black box exporter. So these enable us to scrape and store the metrics data which we are visualizing using our Grafana dashboard. Finally, we also have a load generator application, which is creating some kind of synthetic usage into our website for the purposes of our demo. So this will simulate kind of user activity into our e-commerce application so that we can monitor and observe the impact of the chaos through the dashboard. So yeah, assuming that you all were able to visualize these pods, you have already cleared the first phase of your task. So yeah, give yourself a pat on the back, and please let us know if you were not able to do so. We are definitely here to get you sorted out so that we can move to the next step. All right. Udit, can you please create a poll so that we are aware of the current status of the users?
Yeah.
Thanks. Let me remind you again, guys, that if you're not able to execute any of the commands, or if you're unsure that what any of the step does, please feel free to ask any questions that you have through the chat. I'll try my best to answer those. Right? Looks like most of you have been able to. Awesome. See, it's at 3 votes, 5 votes. Awesome. Most of you are able to access the demo application. Awesome. Okay, let's wait for a while so that all of you are able to complete your setup. All right, guys, awesome. I guess we have 7 votes. I'm assuming that most of you are able to connect to your Kubernetes cluster and are able to view these resources. So I'll just move to the next leg of the setup. So we have right now successfully have create access to our Kubernetes cluster. So let us go back to our guide and see what is the next step that we need to perform. So upon obtaining the setup access, let's try to set up our chaos infrastructure. So for the uninitiated, chaos infrastructure is an agent that sits within your Kubernetes cluster and allows harness chaos engineering to target your Kubernetes application and perform chaos engineering on it. So in order to add a new chaos infrastructure, we'll go back to our harness dashboard, and over here we'll try to access the environments page. And oops, yeah, in our environments page, we'll create a new environment. I'll just name it after myself, that is Neelanjan. And you can choose the type of the environment and select create. Upon creating an environment, we are required to add a chaos infrastructure to here. So we'll just select enable chaos. And upon selecting enable chaos, you are required to select the type of the infrastructure that you're connecting. So for example, if it is a new infrastructure, which is our case, we'll select on new infrastructure and select continue. I'll just name this infra as Neil infra and select next. And now this is the important part where we need to select the type of the chaos access which is provided by this infrastructure. So we must select namespace access over here. Otherwise, your infra will not get validated and it won't set up. For the purposes of this demo, of course, if you are actually using your own Kubernetes cluster later, you can definitely play along with a cluster wide access and see what it does. But for the purposes of this demo, please select the specific namespace access mode for the chaos access type for the chaos infrastructure. And along with that, you also need to properly provide the installation location. So here's the deal with the namespace mode access for the chaos infrastructure. It is only able to access and target the namespace which you will be providing over here for the purpose of chaos injection. You will not be able to target or even discover any of the resources running on any other namespace when you are doing a namespace specific access for the chaos infrastructure. So in our case, our application resides in this namespace. That is, in my case, it's my name followed by dash ns. So I'll provide this namespace over here. So please fill up your namespace accordingly. And of course, definitely choose the namespace access over here. So yeah, those two settings need to be done in the configure chaos infrastructure page, following which we'll just select next. Now, lastly, we need to deploy our Kubernetes, our chaos infrastructure. So in order to do so, we have three commands over here. However, if you will follow the guide closely, you'll find that the first two commands have been already been done for you. So we don't need to execute the first two commands. We can just simply download the chaos infrastructure manifest from here and apply this command into our terminal in order to create the chaos infrastructure deployment. So I'll do that right now. I'll just simply select download. And now that I've downloaded, I'll just simply try to execute this command. Also, make sure while you're executing the command that you're copying, the file path must be correct. So in my case, of course, this file downloaded to the downloads directory. So I'll just modify the path so that I'm in the downloads directory. And I'll just apply this file. So upon doing so, we can see that all the resources, all the Kubernetes resources which have been defined in that installation file are right now getting created. And the successful creation of these resources will ensure that our chaos infrastructure gets ready and is applied correctly. So let us have a quick poll whether all of you are able to follow me along until this stage or not, so that we can move to the next step forward. So just let us know in the chat if you are not able to do so, so that we can help you. But if we right now check the pods of our application, we can see that our installation was successful. Different pods belonging to the infrastructure deployment are already available over here, including the subscriber pod, the workflow controller pod, to name a few. So with that, we have successfully installed our chaos infrastructure, which will allow us to target the chaos into our namespace or this into this Kubernetes cluster. So yeah, that's the second leg of the entire setup. You're doing very good so far. Awesome. I guess most of you were able to set it up quickly. And yes, these sessions are definitely recorded, Vivek. Otherwise, you can already access a recording of this entire workshop through the link I have shared a few moments ago. Otherwise, you can just go to this workshop guide, scroll above, and you'll find the recording via this link. So yeah, congratulations guys, you have been able to set up this chaos infrastructure. Well done. We'll just move to the next part of the setup right now. So if we follow the guide right now, the next step is to add a custom chaos hub. But before that, what is a chaos hub? A chaos hub is a marketplace for the different faults and experiments that are used in the harness chaos engineering. So, for example, if you want to have a fault, you can add it to the chaos hub, and that will ensure its management, creation, and sharing within your organization. Let's say you have a private chaos experiment that you have developed for your harness chaos engineering. You can manage and include its sharing via the custom chaos hub. So there is already a default enterprise chaos hub which is included with all the harness chaos engineering accounts. However, for the purposes of this demo, we'll be connecting a custom chaos hub so that we can access the experiments that we'll be performing as part of this demo. You are definitely free, feel free to target, you can definitely feel free to explore the other experiments which are in the chaos hub, in the enterprise chaos hub. But for this demo, let us try to add the custom chaos hub that we have over here. So to add this chaos hub, I'll go back to my harness platform. And okay, so we didn't check whether our infrastructure is active or not via the UI. So if we press done over here, you can see that my infra is over here connected. So it should be in a connected state actually. If it is says disconnected or error or any other state other than connected, then please let us know in the chat so that we can mitigate it. However, this is how you can verify that your infra is correctly connected. So yeah, ensuring that your infra is correctly connected, please go to chaos hubs and choose to add a new chaos hub. Yeah, you can already see that we have our enterprise chaos hub over here, but ignoring that for now, let us add a new chaos hub. So we need to name this chaos hub something. So I'll name it just CC hub and select continue. Now we need to add a chaos hub connector. So a chaos hub connector is nothing but a git connector, since chaos hubs are nothing but git repositories which are used for the creation, management, and sharing of your chaos experiment and fault artifacts. So I'll just try to create a new connector over here. Assuming that you have a GitHub account, select GitHub connector over here under a new connector, and try to name it something. So I'll just say my GitHub, select continue, and ensure that you have selected a repository type of access over the connection type of HTTP. And over here, you just need to copy and paste the repository, GitHub repository URL, which has been shared over here. So I'll just copy it and paste it over here. So this would ensure that we are having an access to here, this repository, and select continue. Now we need to provide our GitHub URL, our GitHub credentials, in order to ensure that we have a read access to the repository that we are trying to add. So in order to do so, I'll just simply provide my username over here, my GitHub username. In this case, you need to provide your own GitHub username and a personal access token. So ensure that it has at least a repo read permission, the personal access token that you're sharing, in order to continue. So in order to add the personal access token, I need to create a secret. So I'll just select create or select a secret. And since I don't have any secret, I'll just create a new secret. And over here, I'll just name it GitHub personal access token. And following that, I need to add my personal access token over here. So let me just copy it.
Meanwhile, Neelanjan, you can also enlarge the font for the viewers who are facing issues with the font.
Okay. I hope that should be visible now. All right. Yeah. So in this step, as I wanted to repeat, we need to paste the personal access token that we are obtaining from the GitHub. Please ensure that at least it has a repo read permission before adding. So what I'm doing over here, I'm adding the personal access token of my GitHub account as a secret value. So I'll just paste the secret over here and select save. So this will ensure that your personal access token is added as the credentials required for the GitHub authentication. And with that, I'll select continue. And finally, I'll select the connect through harness platform over here. And finally, save and continue. And with that, we can see that the connection verification has been done for our GitHub authentication, which ensures that everything is in order. And with that, we are all set with our new Chaos Hub. Oh, sorry, we are not quite yet. We need to still provide the branch through which we'll be accessing our Chaos Hub connector. So in my case, for example, if we go back to this hub and try to open this hub, we'll be seeing the artifacts that we have here. For example, the experiments folder and the faults that we include over here. But the branch where we are interested is main. So I'll just provide the main branch over here. With that, if I select connect hub, we can see that the hub is successfully connected, and with that, the addition of the hub is successful. So if we open the hub right now, we can see that we have added all the 4 experiments that we'll be performing as part of this demo included over here. So yeah, that is the first leg of this demo. Now I'll be handing over to Udit, who will be showing you how we can execute these chaos experiments and essentially how simple it is to perform chaos experiments via harness chaos engineering platform. The stage is yours, Udit.
Yeah, thanks, Neelanjan. I'll be sharing my screen. Yeah, hopefully it's visible.
Yes, Udit.
Yeah, so I am on the same workshop guide, and we have completed few steps. That is signing up the SaaS platform, accessing our sandbox application, and connecting the hub. That is all we have done till now. The next step will be running the experiments. So you should go to the hub which you have added right now. You'll see some 4 different experiment scenarios are there, and we will performing one by one. We'll first go to boutique card pod bounce experiment. You can get the details of the experiment, what is expected behavior, and what we can derive from this. So it's basically we will be killing on bouncing or killing one of the boutique pod that is associated with a card service. You can see the different services metrics are also available in Grafana dashboard. For example, front-end QPS, card QPS, product QPS, and so on. So you will see what impact does it make, how our website gets impacted if the card service is the pod related to card service is deleted or not available for a certain period, and what are the different matrices and what they represent. So we will all see that. So for that, we'll just go and select the fault. So first step is to go to the Chaos Hub, external Chaos Hub which you have added. There is the other Chaos Hub which is pre-configured, and the other one is one which you have added right now. Just go with that. Select the boutique card pod bounce fault, and you will see some pre-filled value. So these are nothing but the name of the scenarios. You can also change it if you want, and just enable the environment. This environment chaos infrastructure is basically the place where you have installed the execution plane, basically where the fault will carry out. So in your case, you have already, Neelanjan has already helped you to install it. You just move
Sorry to
forward.
interrupt, Udit. Could you please enlarge your screen a bit?
Yeah, definitely.
Thanks.
Hopefully this is good.
Yeah, this
Yes,
works.
thanks. Uh, so we have just selected the scenarios and move forward to the next step. In this step, you will see a pod deletes icon here, and you just go inside it. You will see 3 different stages. The first stage is basically select the target application which you want to inject the fault on. So I'll just go and select the namespace. In my case, it is Udit Gaurav -ns. In your case, your name, first name, last name, and -ns. Select the type of the app, just selected deployment. Then you'll get some list of labels which you can use to target. I'll just go and select the app is equal to card service because I'm targeting the card application. Card service. Now the next step is tune your fault. It is pre-filled value. If you want, you can modify it. Otherwise, you can still go ahead with this. So what are these different tunables? This is allow you to define how many seconds you want to inject the chaos and other values as well. Like, do you want to do a force injection of the chaos? What is the interval? All those things you can set it up using tune fault. The third thing is probes. It's a resiliency probe. You can validate what is happening during the experiment. For example, we have 3 probes here. First one is CMD command probe, which will validate whether your target pod was healthy before and after chaos or not. The second one is HTTP probe, which will continuously check uh, throughout the experiment whether the response code for the service is 200 or not. So you have a front-end service here. You can also view the cart service. This is the page you are getting for that. And we'll be continuously checking whether the response code is 200 or not. If it is not, this probe will fail. The third one is Prometheus probe. Here you have a matrix, and again a validation is added that the value should always be less than or equal to 120 milliseconds. So it's website latency, that it should not increase after this. If it increases, the validation will fail. So these 3 validations we have made. You can add some custom validations. You just need to click on this button and just select the type of validation you want to make, and you can do that. Yeah. Moving forward, I just close this. So all these things we have configured: application information and the application information, the tune fault, and the probe. Then you just need to click on the run button, green button here. Once you click on the run button, you will see a new run is being scheduled, and you will see some status running and some more information. To get some more information, just click on this. You will get a page where you will see some few options like resiliency scores. This will be calculated, evaluated based on what probe result is, what is the experiment result is, some description, and on the other side you will see the execution details. So I'll just go to that one. So you'll see a node is getting it is in running state. Is basically an installation fault. So there will be a couple of steps in this. So first step will be to install the chaos fault, which will pull the fault template, and the next step you will get the injection logic running. So we'll wait for a couple of seconds, and once the fault template is pulled, and we will go to the chaos injections. Yeah, so you can see that the first step is done. In the second step, the chaos injection will occur. Before that, it will do some pre and post chaos validations, like the probe validations, what we have added, and all those validations it will perform. You will see here some different tabs which will talk about the logs of the experiment, real-time logs, what is running. This is a detailed view of what the experiment is doing right now. Probe will be talking about what are the result of probe validation that we have asked for. The third one is chaos result, which will talk about the detailed analysis of the result. So since the chaos is running, I will first go and to my website and refresh it. Oh no, I saw there is an internal error. It means that the fault which we have added is not resilient to the application. And you are seeing that the website is down. What is the metrics we are getting in the Grafana? Oh, so we saw that the probe success percentage has dipped. We have targeted card QPS, so you will see a good response code is the green one, and the failure response code is the this one, yellow one. And you'll see the high straight dip in the yellow response code. Green one, which is basically a query per second, which is successful query per second, and the yellow one is the other one, unsuccessful. So here and similar effects on the other things. You'll see that the latency is spiking up, which means the availability is decreasing. So this is our observation on this fault. there could be different ways you can correct it. One such way is increasing the replica of the fault. So right now, we'll just go back to the execution plane, execution details. And the last tab which I skipped was the fault configuration. It is nothing but just the information about the fault for future references if you want to see. So once the fault is completed, once the experiment is done, you will see all these probes and chaos result will be updated with the value. I hope you all are catching up. Just let me know in case you have any issues in the chat. So once the chaos is done, you will see the recovery. So the website will also be back. Also, you will see a recovery in the observability metrics. The QPS value will retain. Access duration will again come to that certain value. So all those things. And this red area, you must be wondering what is this red area. This is a chaos annotations. So this is from the chaos exporter matrix. This is a matrix that will allow you to know when the chaos has started, at what time the chaos has started, and what time it is completed, so that you can exactly evaluate the impact of chaos at that point of time. Yeah, so we can see that the recovery is almost done, and the experiment seems to be failed, which was expected. So you can see there are two probes that were passed and one was failed. So now to get the more information about it, just go to the probe tab. You will see different probes here. The first probe was basic health check before and after the chaos, that is passed, and that was expected to. The availability, you will see that the front end service wasn't available. We saw some 500 status code internal error, so that wasn't available. That's why the HTTP probe validation got failed. It is not equal to 200. The third thing was latency. We are expecting it to be less than equal to 120, and it keeps to be below this value. So it seems to be passed. So these are the three probes we have added. And the final overview of the chaos result, you will get it in the third tab, where you will see that the final verdict is failed, the phase is completed, and what are the exact error you are getting in this. So you'll see that HTTP probe error you are getting in this, as we discussed. And what are the, if you run it some more times, you will get some more information about the pass runs and the failed runs. And you will finally get a probe success percentage of 66% based on the three probes you have added. So this was all about the first experiment. I hope you are all aligned with it, and we are good to go with the second scenario. Meanwhile, anyone having any questions? Okay.
We can move forward with it.
Yeah. So now I'll just go with the second chaos experiment. The first one was Gothic card bounce we just saw. The second one is related to degraded network. So this may be a issue you can face, that you may occur some latency in your services. Then what will be the impact of it on the overall microservice? What will be the availability of your application? So all you can evaluate. I just, for this one, just go to the custom hub again and select the network integrated experiment. And we can just change the name if you want. Otherwise, you can keep the same as well. I'll just modify a little bit. The infrastructure selection, all the other steps will be more or less same what we did earlier. Selecting the application information. You can select application based on the labels here. Tune the fault. Here we are providing a 2000 ms millisecond of latency injecting, and we are injecting 2000 ms, and for how much duration we are injecting this chaos is for 60 durations. You can also add some jitter value here. Jitter is nothing. You will just, for example, if you have provided 100, the latency will be in between 1900 to 2100. So it will be a random value. Now we'll move forward, and there are some different types of probe. These are all same. We are again checking the same CMD probe, same HTTP and Chrome probe, and we'll see what are the result of these probes against this scenario, this particular experiment, a network experiment. So we have tuned the fault, and I just go to run it. Yeah. So this time we have selected network experiment. So you will see a latency spike in the dashboard for that particular service, which is under target. And the steps of execution will be again similar. You'll again see some installation of chaos fault and the injection stage, where all the probes and everything will run. You can also halt the fault if you feel something went wrong and you want to just abort the fault. You can just click on this halt button and it will abort the fault. You can edit and download the manifest if you want. If you want to change the tunables in the next execution, or you want to store this manifest for the next execution, you can all do that. If you want to view the manifest, you can just click on this button. Yeah. So we have now in the second step, which is again the same chaos injection stage, where some pre-chaos and post-chaos checks are being performed, and you will get the detailed uh, explanation of what is occurring right now here in the logs. So, and simplified view is already available with probe and chaos result. So now again, we'll go to the application and just try to access it. You'll see that it is loading. There is a perfect 2 seconds of latency, nearly that or even more than that, you can see. And if the website is taking some time to load, if I open it in a new tab, yeah, and yeah, it is taking that much time. And now if I go to the dashboard again, you will again see when the chaos got started, the availability decreases, and this time you'll see a very high spike on the access duration. The latency has increased a lot. The QPS value is again declining for the card service. So these are the impact that is occurred. So in real world scenario, you can also correlate with your application when suffers from such situation. Then what happens to the different services and how to overcome this. You can see the latency is spike up to 500 ms. It will go up to 2000, whatever value we have provided in the chaos injection tunable, and other values as well. The website is behaving absurd in this case. And once the chaos is done, it will again revert. This is our second scenario. Hopefully, we are all aligned with these two scenarios, what we perform. So we have evaluated what will happen if an replica of pod is evicted or deleted with some issues in the first scenario, in the first experiment. In the second experiment, we saw what will happen if I have some network degradation, network loss in my boutique service or your own application. So what will happen and how we can reproduce such scenarios using the chaos experiment. So these were the two scenarios. I'll just come back to the results once it is completed. Yeah, you can again say that it is completed. And this time you'll see only single probe has passed and 2 probes have failed, which was again expected because the application was healthy before and after chaos. But at the time of chaos, we saw a high latency, which actually can't get a 200 response code within the time frame which we mentioned. And the second one failed because it actually crosses this value, the latency value of 120, is 5 up to 2000 latency. And the chaos result will again explain the same thing in a very short way, brief way, that your value actually crosses that thing, and you will get the failed run as one, and the probe success percent this time will be 33%. Only one probe has passed since. So, and these are the fault configuration descriptions. Okay, so this is the second scenario. Now we'll move to the third one, which is from our guide, we'll just go. This scenario is basically CPU starvation. This is again a very common situation when a lot of request is coming. You will see a resource exhaustion in your application occurs. So how to reproduce them with the experiment and what possible solutions you can think of. So you can just reproduce using this scenario called boutique card CPU starvation. This will target the card service and spike up its CPU usage. So I will again follow the same steps. Now you must be aware with these steps. Just selecting the app information. Once you have run this scenarios, you need not to follow these steps again and again. You can just go and rerun it, or you can just store it and run it. There are different options that we provide. Uh, so this is the tunable. Coming back to the experiment, this is the tunable. We have 60 seconds of duration and one core CPU with 100% load, and we just go ahead with the default values along with the same probe that will check the app health check and the availability check or using HTTP and Chrome probe. So we'll just go with the same things and just run the experiment. Yeah. So the third scenario is basically spiking up your CPU utilization to one core. So will it impact the the microservice, and will our validation will fail? We'll check that, and there will be let it perform the couple of steps. Till then, I will just go ahead and explain the last scenario which we are having in our hand. This is a multi-fault scenario. So you must be observing till now what we have done is we are selecting one chaos fault per experiment and running the experiment against the service. So there is option, you can select multiple chaos fault either in serial way or in parallel way. For example, you can run CPU, memory, IO in serial way on a certain fault, a certain service, or you can tune them in parallel. I will show such one case of parallel after this. So yeah, we have now in the chaos injection stage for this scenario. This will again scenario where we have spiked up the CPU usage, but I can see there is no downtime due to it. The values are also not much deviated because of this. So our expectation is that the probe should succeed this time, depending on what effects we see. Okay, so we'll see the results once the experiment is completed. You can also run it on your sandbox environment and check these scenarios. Now, coming back to the last fault, which is a multi-fault scenario. So, as I mentioned, you can tune multiple faults in serial or parallel fashion and inject on your microservices. So, this particular last scenario will be doing that thing only. We'll be just going and selecting the uh, service and performing some parallel chaos injection on it. So you'll see that the three chaos fault are there. This is basically pod CPU, pod memory, and pod IO stress. We are all injecting at the same time on the same application, on the same service. And we'll see what happened when we what happens when once we run all the three fault at the same time, whether the application survives or not. So we'll just keep the default values, and this time we have just checked a single check we have, that is pre and post chaos check. The motive of showing this particular scenario is how you can tune the faults in parallel way or serial way, multiple faults. So we are also out of time. So we'll just run the scenario and show the execution. Also, you'll see some older execution got passed. So all the three probes got passed. The validation got succeeded, and the experiment is also completed. It was able to survive. The service was able to survive even after one core CPU hog on it. So you'll see a resiliency score of 100%. The last scenario is basically how you uh, inject the parallel faults. So it's just a gist of how you inject it. And this is what you can try it out on your sandbox environment, and you can just play around it. Once you are comfortable with these scenarios, you can also choose some experiments from Enterprise Hub. There are a lot of experiments based on Kubernetes. You can select them as well, and just try out creating your own scenarios and run the faults. Yeah. So I think that's all. If you have, you can see the execution in parallel. We'll see the results the very similar way. So the story will be more or less similar. It's all about how you tune it. Yeah, that's all we have for the experiments execution section. Any other questions regarding the whole workshop, that you can just ask, or we can just connect on the Slack channel and discuss there.
Yeah. Thanks, Nilanjan. Thanks, Udit, for that walkthrough. That was really great. And also, it lets users know that it's not that difficult to run their first chaos experiment. Thanks for that. Yeah, thanks, folks, for joining. We do have another interesting sessions lined up, so I would request you all to jump on that as well. Thank you.
Sure. Just before wrapping up, please remember, guys, if you guys have any questions, please join the hashtag Chaos Carnival channel. We are there to help you guys. If you need any help with the demo setup, or if you have any questions in person for us, please feel free to reach out, and we'll be definitely be very glad to help you guys. So yeah, with that, we are wrapping up over here. Thanks for joining this workshop. See you around.
Thank you, everyone.
Thanks, everyone.